Hello, this is Unha Yeo, and you're watching a summary of our paper CAIR for Fast and Lightweight Multi-Scale Color Attention Network for Instagram Filter Removal, presented at AIM Workshop ECCV 2022. Here's an example of an image of some apples and the same image with a filter. When training a deep learning model with a pure image, the model learns to classify the image as apple. But this model could predict the same image but with filter as orange, which is a wrong answer. Therefore, reverting a filtered image to its original image is necessary for various computer vision tasks before training or testing. Kinley et al. Proposed an Instagram filtered fashionable image dataset, which is a set of high-resolution fashionable images with 16 different Instagram filters. This figure shows an example of filtered images in the dataset. This slide shows the results of existing Instagram filter removal methods. IFRnet shows strength in PSNR, and CIFR shows a high SIM value. These two methods use an adversarial training strategy for autoencoder-like architectures, which is exceedingly complex and time-consuming. In the figure on the right, these two models remove filters quite well. Still, the restoration is insufficient in terms of color. NAFNet is one of the state-of-the-art image restoration methods. It shows better results than two methods mentioned previously. The visual results also show that result of NAFNet is more similar to the original than result of the two. Our proposed network CAIR is excellent in terms of both PSNR and SIM. Also, CAIR-M has fewer parameters and less operations than the existing methods. Visually, CAIR shows the most similar restoration result to its original. Let me explain how we achieve this. We use NAFNet as our baseline to take advantage of its simplicity and low complexity. NAFNet adopts UNet architecture and consists of simple baseline blocks called NAF blocks. Please refer to reference number 4 for more details. This is the basic version of our proposed network CAIR, which takes single input image. The main difference with NAFNet is that CAIR-S has a color attention module, which takes an input image and outputs a color attention map. The color attention module is on the next slide. Here is the CAIR multi-scale input version. The input image IF is downscaled by a factor of 2 as going down to the lower level, and each color attention module takes the input of its level and image from the upper level, then extracts color attentive features. The color attention module is described on the right side. It consists of Gaussian blur with a standard deviation of 12. This strong blurring operation ensures that only the color information can be extracted from the input image IFK-1. The structure, content, and fine texture come from the lower level image IFK, and some other convolution layers are used to get rich informations. To improve performance, we use an ensemble learning strategy. The ensemble network learns to combine the two results from CAIR-S and CAIR-M. This result is denoted as CAIR asterisk. CAIR is much faster and has fewer parameters than the previous Instagram filter removal methods, while obtaining more accurate results. We have summarized quantitative results of several methods on the IFFI dataset. CAIR-S and CAIR-M outperform IFRnet and CIFR in all metrics by large margins. CAIR-M also shows better performance than NAFNet with fewer operations. CAIR asterisk achieved the best PSNR and SIM among compared methods. CAIR, which has the strength of the color attention module, successfully removed filters and restored color information.